The sun goes down, the stars come out, and all that counts is here and now. My universe will never be the same. I'm glad you came.
Cast a spell on me. You hit me like the sky fell on me, and I decided you look well on me, so let's go somewhere no one else can see you.
I see your dirty face, hide behind your collar. What is done in vain? Truth is hard to swallow, so you pray to God to justify the way you live a lie, live a lie, live a lie. And you take your time, and you do your crime. Well, you made your bed, I made mine. Because
No fighting.
We got the refugees
No
up here.
fighting. No fighting. Shakira,
I
Shakira.
never really knew that she could dance like this. She make a man wanna speak Spanish. Como se llama? Bonita, Picasa,
Shakira,
su casa.
Shakira.
Oh, baby, when you talk like that, you make a woman go mad. So be wise and keep on reading the signs of my body. I'm on tonight, you know my hips don't lie, and I'm starting to feel it's right. All the attraction, the tension. Don't you see, baby, this is perfection.
Hey girl, I can see your body moving, and it's driving me crazy. And I didn't have the slightest idea until I saw you dancing.
Mirrors are an example of a near-perfect reflector. Human beings can only perceive light when it has been reflected off of a surface. For example, when light hits an object, some of that light is reflected back at us, and this is what we perceive. Mirrors are highly reflective and can be used in conjunction with solar cells to increase their output. One way to use a mirror is to use a parabolic mirror. A parabolic mirror takes light from numerous angles and directs all of that spread out light to one concentrated area. By doing this, we can use a smaller photocell to produce the same amount of electrical output. The amount of electrical energy produced is directly related to the amount of photons that enter the cell. So the more concentrated the light is, the more electrical energy that will be produced. Another example is the Kimberlina solar plant in Bakersfield, California. This plant uses a series of electronically angled mirrors to concentrate a large amount of sunlight to one centrally located boiler. This system does not use photovoltaic cells, but instead uses the heat component of light to boil water, which creates turbine rotating steam for electrical power generation. This system directs the mirrors to the optimum angle at all times of the day to get the maximum amount of energy to the boiler at all times. Lenses have a very similar effect on solar concentration. Lenses take a spread area of light and focus it into one small concentrated area. Just like using a magnifying glass as a kid to catch things on fire, the lens concentrates the energy of light. In the same way as a parabolic mirror, a lens can take a spread area of light and condense it into one small area, allowing for more compact and cheaper solar panels to be used, while still producing the same amount of electrical output. Semiconductors are conductors that have both conductive and insulative properties. Depending on how we manipulate them, they can be either a conductor or an insulator. When energy is supplied to a semiconductor, its properties change. The photovoltaic cells are made up of semiconductors. This is important because just like a battery, a barrier is needed to separate the anode and the cathode. The semiconductor material of the photovoltaic cell allows an electrical barrier to be formed which creates an electrical potential difference. This means that the electrons cannot cross the barrier of the cell, but instead must travel through the circuit in order to reach the other side of the barrier. Power is the product of both voltage and current. As the sunlight shines on the photovoltaic cell, the movement or flow of the electrons through the circuit provides the current flow, while the cell's electric field causes the voltage. These two components combine to give us power.
Broken photocells that we use in this project are photovoltaic cells. As you've seen, they take any light source that is powerful enough and converts the light energy into electrical energy.
As photons hit the photocell, they have a potential to be bounced or reflected off. To resolve this issue, the manufacturer of solar cells uses an anti-reflective coating that allows more of the photons to be absorbed. Light reflected is wasted energy, so it is in our best interest to allow as much light as possible to be absorbed.